So my problem was 1 over 1 minus 10 squared x plus 1 over 1 minus cotangent squared x equals 1. So first I turn those into sine and cosine respectively, the tan and cotangent. So of course 1 minus parenthesis, so sine over cosine, of course the x's, and I mean just leave the squared out, doesn't really matter, and plus 1 over 1 minus cosine over sine, the x's, the parentheses, and then the square. And now you take your common denominators, so that's cosine and sine. So you take those least common denominators and you'll end up with 1 over cosine square x over cosine square x minus, on the bottom still, sine square x over cosine squared x. And then the same for the other side. But that one was sine as its common denominator, least common denominator. So it's sine squared x minus cosine squared x over sine squared x. Alright, and from there, you go ahead and solve them. So that means that you have the denominators, so they stay the same. Denominators stay the same. I'll show you what I mean. Cosine x sine squared x. As you can see, that's the numerator combined, I guess you could say. And then combined cosine squared x. And then there's an over 1, of course, above it. And then the same goes for here. The denominator over your numerator combined squared x minus cosine squared x over 1. And so now, once you've did the common denominators and such, you'll end up going with a cosine. You flip the denominator with the numerator, and you'll get cosine 2x sine 2x. And now this one's going to be a minus squared minus sine 2x over cosine 2x minus sine 2x. And the reason you were able to flip it from sine minus cosine to cosine squared x minus sine squared x here is because you multiplied by -1. And once you do this, you bring them together like last time, which will give you cosine squared x minus sine squared x over, of course, same denominator, cosine squared x minus sine squared x, of course, giving you 1.